We're going to start with section 4.3, and we're going to be talking about congruent polygons, but I'll be honest with you, most of what we talk about today is going to be triangles. So you're going to be comparing triangles, and we're going to be talking about their corresponding parts. And what that means is when I have one angle of one triangle, it's going to match up with an angle of another, or a side of one triangle is going to match up with a side of another. So it says, in two congruent polygons, all the parts of one polygon are congruent to the corresponding parts or matching parts of the other polygon. These corresponding parts include corresponding angles, there are 3 of them, and corresponding sides, there are 3 of them. So if we're talking about triangles, I should say, we have 6 parts. Now, if we're talking about parallelograms or rectangles or rhombuses or squares, we would have 8 parts. So today we're going to focus mainly on triangles. Just know that that's going to be 6 parts, and if it was something bigger like a quadrilateral, it would be 8 parts. Okay, so down here is going to be the definition of what congruent polygons are. So it says, two polygons are congruent if and only if their corresponding parts are congruent. So when you guys think about triangles being congruent to each other, you literally have to check 6 parts. So you're going to look at the angles, and you're going to see if you have 3 sets of angles that match. So if you guys go to this picture right here and you look at angle A, does everybody see that it has 2 arc marks on it? That is going to match H, which also has 2 arc marks on it. So that means those angles correspond, and they're congruent because they're marked the same. All right, let's go to the next set of angles. So go to angle B, it has 1 arc on it. Go to angle J, it has 1 arc on it. So that means those 2 angles are corresponding and they're congruent. And then likewise, C has 3 marks and K has 3 arc marks. That means those angles correspond. So now you know that you have 3 sets of corresponding angles that are congruent. Then you're also going to look at the sides. Well, you're going to have 3 sets of corresponding sides. So how would you know which sides correspond to each other? We'll go to the picture. So AB has 1 tick, so HJ has 1 tick. That means those sides correspond and they're congruent. Then it says segment BC has 2 ticks, is congruent to JK, which has 2 ticks. And likewise, AC has 3 and HK has 3. So when you guys get done marking your pictures, you would be able to mark 6 body parts that match the other 6 body parts. So I'm going to say 6 parts are congruent. Okay, so if that is the case, then you will be able to write something called a congruent statement. So a congruent statement is a statement that matches up all the pieces of the triangle. So the cool thing about a congruent statement is I could cover up the picture and get rid of it, and you could still tell me which parts match. Watch how cool this is. So I'm going to ignore the picture for a second. Angle A is congruent to angle H. See how I know that? They match up in their names. Angle B is congruent to angle J, match up in their names, and angle C is congruent to angle K. Also, segment AB is the first and second letter. That is congruent to segment HJ, and so on and so on. So the cool thing is you can tell which body parts match up by the congruent statement. All right, so come down here because that is not the only congruent statement that would work for these triangles. If you look at this congruent statement, the body parts still match up. Angle B still corresponds with J, angle C still corresponds with K, and angle A still corresponds with H. So that congruent statement would also work just like this congruent statement would. Now, when you look at this one is not valid. So look at why that wouldn't work. So do you guys see how, for instance, angle B is supposed to match up here? Angle B is congruent to angle J, right? Does that match here? No, that does not. So this would not be a valid statement because your pieces are not matching up. So the moral of the story is when you guys go to do a congruent statement, you have to make sure that the body parts match up. Okay, so we're going to only do the congruent statement for this, and then you guys are going to go back and you're going to list the 6 corresponding parts. Okay, let's make a congruent statement though. We're going to practice. So triangle something is congruent to triangle something. And when we do this, we have to make sure that the order matters. All right, when you name the first triangle, it does not matter how you name it. So I'm just going to go JLK. Is that the only name? No, that's just the one I picked, JLK. Now, I want you to go to this picture over here and match up the pieces that go with JLK. So look at J. J is 52. Oh, which angle is 52 in the other triangle? P. That has to come first. Then L. Okay, L is 50 degrees. Go over here. Which one's 50? That's Q. That has to come second. And finally, 78 is K. So we need the 78 over here. It would be M. So if I name my first triangle JLK, then my second triangle has to be PQM. Now that's not the only name. Like for instance, I could go JKL, then I would have to go PMQ. That would be another alternative. You just have to make sure that order matters. All right, now it gets pretty annoying when you guys have triangles and you have to talk about all 6 parts. That is a lot of body parts to have to talk about. So the question always comes up, are there shortcuts? Do we really have to do all 6 parts when we see if they're congruent? And the answer is no. There are going to be shortcuts, or I wouldn't have it down here. So it says, in 4.3 above, you prove that true triangles were congruent by showing that 6 pairs of corresponding parts are congruent. Is it possible to prove 2 triangles are congruent using fewer parts? Let's say yes, because otherwise I wouldn't be bringing it up. So there are 4 triangle congruent shortcuts. These are going to allow you to show that 2 triangles are congruent using just 3 pairs of corresponding parts. So we are going to talk about the shortcuts below. That way you don't have to do all 6 parts, you can just do 3. Okay, in a normal school year we would discover these and I would have you guys come up with the ones that work. We don't have time. So I'm going to tell you the ones that work and the ones that don't, and then I'm going to show you how to apply them. So there are 4 shortcuts that work. So do 1, 2, 3, and 4. And I'm going to show you what these mean in a second. We're just going to list them. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. Now, angle, angle, side could also be side, angle, angle. So I'm going to list those as the 4 that are going to guarantee congruence. Now over here, there are going to be shortcuts that don't guarantee their congruence. I'm going to tell you the 2 that do not work. The first one is AAA, and the second one is SSA, or ASS, but we're not going to write that on the paper. So basically, the order of these letters will tell you if something works or not. So let me kind of preview what these are going to do. If you have 3 sides of one triangle that match 3 sides of another, then the triangles are twins, and you don't even have to check the angles. If you have 2 sides of a triangle and an angle that's between, called included, if that happens with another triangle that has 2 sides and an included angle that match, then your triangles will be twins. This is 2 angles with a side in between, and this is 2 angles with a side not in between, which is the same as this, it's just written backwards. These mean that 3 angles that match 3 angles don't mean they're twins, and this means that 2 sides and an angle not in between won't work either. So when I tell you those, you're probably like, what does that mean? Well, I'm going to show you on the next page here. So flip your page over. It's going to take a little getting used to, but I want you to picture this. I want you to picture that the door knocks, okay, 2 triangles walk in, and you don't know if they're twins or not. You know how you've seen people that kind of look alike, and you're like, are these people twins? And we're going to decide if they're twins by saying yes or no and using the shortcuts. So let's list the shortcuts again at the top here so we have them. So the ones that work are SSS, SAS, ASA, AAS, which is the same as SAA. So it doesn't matter which order you write those in. Okay, these are don't use or don't work, AAA, and SSA, which is the same as ASS, but we're not going to write that. Okay, so now let me show you what I mean by this. So the instructions say decide whether or not you think that these are congruent or twins. If there's enough information, give the shortcut that you could use. If there's not enough information, we're going to write CBD, which means cannot be determined. All right, so let's look at number 1. We look at the first triangle and we see that we have 2 angles and a side in between. So the order that this is in would be angle, side, angle, because the side is between the two angles. So this triangle is an angle, side, angle. Now we're going to go to the other triangle and see if it's marked the exact same way as this one. Does it have two angles with a side in between that's marked? Yes, so this one is also ASA. So these two triangles will actually match each other. They'll be twins. You don't have to check any of the other parts because that shortcut is guaranteed to make them twins. So you're going to say that they're twins by ASA, which is called angle, side, angle. Keep in mind the side is called included or between the two angles. Okay, we're going to do a bunch of these, by the way, just to practice. Okay, number 2. So right now we have two angles. But do you guys see how there is a reflexive side that they both share? It's called reflexive because they both have it. So you are allowed to put a tick on that shared segment. It's a shared segment between them. All right, so I'm going to cover up this triangle, and I want you to look at the triangle that we have right here. You have two angles this time, but the side is not between them. So you have to think about how you're going to order the letters. It's not going to be ASA, it's going to be AAS, where the side is not between the angles. Now, could you write it as SAA? Sure. So let's go look at the other one. We have two angles, and the side is not between them. So this one is also angle, angle, side. So the point is, if this triangle has two angles and a non-included side, and this triangle has two angles and a non-included side, and they match, then they are going to be twins automatically. You don't have to check anything else. You can say they're twins by angle, angle, side. Keep in mind, you could write it as side, angle, angle, and that's correct also. So right now, take a second to look. What is the difference between writing it this way and writing it this way? This way means the side is between the angles, and then this way means the side is not between the angles, which is called included. You'll see that in your vocab tomorrow. Okay, go to number 3. So I call this a bow tie picture because it looks like a bow tie, and we have vertical angles in a bow tie. So I want you to go ahead and mark the vertical angles. That's by VOC. Now we're going to see if we have enough to say that these are twins. Well, we have different options. Actually, I wouldn't even need the vertical angles because if you look up here, you know that side, side, side makes them twins. So if this triangle has 3 sides that match this triangle's 3 sides, and they're each side, 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 then that's enough to say that those two will be twins. Or if you don't like that, you could also do side, angle, side, because the angle's between the two sides. So if you choose that, that would also be an option. Side, angle, side could be used for that picture too. All right, go to number 4. Am I allowed to mark a reflexive side? No, they don't even touch. Do they have vertical angles? No, they do not. So this is all I have. Well, go up to your shortcuts. There's no shortcut with 2 letters. We don't have that. So we have to say CBD because we just don't have enough for those to be twins. We don't know. They could be, but we can't really determine, so it's called can't be determined. All right, number 5. These share a reflexive side. Go ahead and double tick the reflexive side. Now I'm going to cover up one triangle, and I'm going to think about what letters I would need to order this. So it has 2 sides and an angle that is between the 2 sides. If you look, that angle is connected between the 2 sides. So you would list this as SAS. Okay, now look at your other triangle. Does it have the same thing? Yes, it has an angle that's between the 2 sides that are marked. It's called included. So this one would also be SAS. And now we have enough to say they're twins. They will be twins by the shortcut SAS. We don't have to check anything else, just those. Number 6. When you look at these, you'll notice that there are 3 angles in the picture marked. So we go up to our shortcuts and we ask ourselves, does AAA guarantee that they're twins? AAA is not going to be enough to say they're twins. So you go back and you see if you could mark any sides. No reflexive side, no vertical angles, nothing else you can mark. So you say, I cannot determine. I do not know. They could be, but we don't know. So you say CBD. Not necessarily, but could be. All right, go to number 7. So in 7, go ahead and mark what you think you could mark. There is something you're allowed to mark in this picture, and it's called a shared segment. So you would need to double tick that shared segment. Now I'm going to cover up one triangle, and I'm going to look at how I would order these letters. So I have two sides and an angle. So you have to ask yourself, is this SAS or is this SSA? So that A is not between the two equal sides. See how it would be here if it was SAS? It's not there. This is SSA or ASS, but you probably don't want to write that on your paper. So write it in this order, and then I'm going to cancel it out, because even though this one is SSA also, if you go up to your does not work or does work, this one is not guaranteed to make twins. So we don't know. They could be, but you're going to say CBD. All right, number 8. We have 3 angles. Is there anything else we can mark? No, there's nothing else we can mark in the picture. So this is a CBD, and the reason it's a CBD is we know that AAA doesn't count as a shortcut. It's not going to work. All right, number 9. Think about what number 9 would be. I cover up one of these. So you have to ask yourself, is your side included or not included? Is your side between the equal angles? Yes. Now think about how you would order that. It would be ASA. The S would need to be between the two A's to show that it's included. Okay, is this one the exact same? ASA. Yes, that means that is one up here in the list that works to make twins. So we'll say that they're twins by ASA. All right, we're going to finish these 3 and then we'll be done with this section. So for this one, when you guys look at it, it looks like they might be twins. I mean, they're drawn kind of the same, but think about the letters here. So this is 2 sides and an angle, but the angle is not included. So this would be an SSA, and that's because the angle would need to be here to be SAS. And this is an SSA also. Okay, you are not going to be able to use that. If you look at the top, that is not one that guarantees twins. It does not work. So you'd say CBD. All right, number 11. Go ahead and tick your reflexive segment, and then look at how you would order this. Cover one up. You have 2 angles and a side. So you have to ask yourself, is it ASA or AAS? Well, the side is not between the equal angles. So this is AAS, and on this one, this is also AAS. That is one that works. If you want to write it as SAA, you could write it that way. Okay, last one. Cover one triangle up. This is ASA. Do you guys see how the side is sandwiched between? So the side is in between the angles, so that's ASA. And then this one is also ASA. That means they are going to be guaranteed to be twins by ASA.